Right, for domains, we have a rule that if we have square roots, or any even root actually, of some quantity, I'll call it q, the rule is that that thing must be greater than or equal to 0. So here we want x squared minus 4, the input of the square root, to be greater than or equal to 0. Now for inequalities, we treat them almost like equalities, but we end up with intervals that we need to check. So we're going to factor this expression. That's x plus 2 times x minus 2. That's the difference of squares formula. And if it were equal to 0, I would simply have x equals negative 2 or positive 2. And so I need to check my different intervals. And so I'm going to draw a little number line here and label my negative 2 and positive 2. And then I just check each of these intervals to see if they work out. So if I say let x equal negative 3, if I plug that in, I can plug it into any of these inequalities. I'm going to plug it into this first one. Okay. Well, negative 3 squared minus 4, that's 5. And that is certainly greater than 0. So that works. That interval works. And then I can plug in a value in between negative 2 and 2. I'll plug in 0. If I plug that in there, I get 0 squared minus 4. Well, that's equal to negative 4. That is not greater than 0. So that does not work. And then I check the value up here. I'll plug in x equals positive 3. And if I do that, I get positive 3 squared minus 4, which is again 5, which is greater than 0. So that works. And then finally, I need to determine if my endpoints are included, the negative 2 and 2. Well, if I plug in negative 2, it's going to equal 0. That's how I found negative 2. And I am allowed to equal 0. So negative 2 does work. That's going to be a filled-in hole. Same thing with positive 2. If I were to plug that in, I would get 0, and I'm allowed to equal 0, so that will be included. So my domain are these two intervals, from negative infinity to negative 2, which is included, union, and then 2, which is included, to infinity. So there's my domain in interval notation.